Okay, and so here we go, and this is our second video in our series on inequalities. In the first one we looked at I'll put my teeth back in. We looked at linear inequalities. In this one we're going to have a look at quadratics. So let's have a look at an example. So we're going to proceed in exactly the same way as we would if it was just a normal solving a quadratic equation. So this one, we'll factorize it. There we go, x minus 12, x plus 5. Now, if this was just a normal equation, if it said equals rather than having the inequality sign, we'd just be saying, okay, you know what, that's x equals 12 and x equals minus 5. Now, this is not an equation. We've got this inequality sign here. There it is. And so what we're going to do is use these two values, and we're going to refer to these things as the critical values. And you need to make sure you're stating them clearly in your solution. That's why I've put that in block capitals there. It's absolutely vital you write down those and state that they are what we call the critical values. The reason for that is we've got to think very carefully about those in terms of how that impacts on our inequality. And in order to do that, we need to think about the graph. And again, I highly recommend drawing a little sketch of that quadratic curve. There it is with our values minus 5 and 12. This one is a real bugbear of mine. Students will, if they just try and jump straight to a solution, chances are they're going to get an inequality the wrong way around, get the signs point the wrong way. So please, if you don't take any of the advice from these videos, take this point and just draw yourself a simple sketch. It is a 10-second job and it is well worthwhile you do that to make sure you're thinking clearly and getting these things correct. Right, that's enough ranting. I'll get back off my soapbox and continue on with the video. So we've got this this curve here. We've got our sketch, and what we need to consider is, well, where on that sketch are the values of x squared minus 7x minus 60 less than 0, and that is clearly anywhere below the x-axis, because anywhere in that green zone there, if we're plotting those points, we've got negative values because they're below the x-axis. And what that tells us is that is the range of values where the inequality is equal to or less than 0. So the values we've got here, but that's anywhere in between here. So because we want the x values, so what it tells us is that for any value of x in between 12 and minus 5, this thing here will be less than 0, which is what we want. So our solution we can write as minus 5 is equal to or less than x, which is equal to or less than 12. Now, the other thing to note here is we've got a single region on our graph here. It's just one continuous green line going in between our values of x is minus 5, minus 12, which means we can write it as a single inequality here using this kind of double inequality notation. And there we go. Inequality solved. On we go. Different example. So we've got 9 minus x squared less than 0. So again, it's still a less than, but the fact that we've got a negative inequality, a negative quadratic here is going to have an impact on our solution. That's why the drawing the sketch is so important. Okay, so let's just have a look at it. So factorize it. In this case, it was a difference of two squares, 3 minus x, 3 plus x. Our critical values, 3 and minus 3, there they are clearly stated. There's our sketch, and I'm going to put a little note there. Always draw the sketch so you can think about what's happening. And so now we need to start where on our sketch we less than 0. So we've got two completely separate regions here. We've got one region here, and we've got a separate one over here. And what that means is we've got two completely separate inequalities that we've got to state. We've got our first inequality where this region here is for any values of x that are from minus 3 downwards, so coming down here. And we've got our second region that's here, that is for any value of x greater than 3. So there we go, two separate regions. There's our one inequality, and there's our second inequality. And that's happened because in this particular case, we've got that negative quadratic giving us two completely separate regions. And that's primarily the reason why you need that sketch, so you're thinking very carefully about whether you've got one region or two to draw. Now, the final thing to note with this one is that you might be looking at our inequality top and say, well, do we really need to do this by factorizing or hassle of drawing the curve? Well, the answer to that is actually no. But it leads to problems, and I personally prefer this method up here. But let's just have a look at what happens if you don't. Well, we can take this and say, okay, let's just take that, move the x squared over there. We've got 9 just strictly less than x squared. I've just written that the other way around again because it's just intuitively it makes more sense in my head if we write it that way around. And then clearly what you do here would be to square root and you're going to get a value of x equals 3. But the thing to be careful is square root gives you plus or minus 3. So, and that's the bit that worries me. That's the bit that students tend to forget. They just go x is greater than 3. Have a single one where they'd end up with this solution here, but completely miss the negative one. So that's why, in my view, it is more sensible and safer to go with this method up here. But as you can clearly see, we still get the same result if you decide to do it a slightly different way.